Hello everyone. In this video, we discuss the would-be or thought essay type question of the 2023 MAKAUT question paper of the subject of utilization of electric power of the Department of Electrical and Electronics Engineering. So, first question is the state and explain the laws of illumination. The illumination is depends on the following factor. So there is a sufficient way away, otherwise point source or otherwise sufficient away to the surface of the river. And this position, so illumination is laws, three laws. Yes. First law is that illumination is directly proportional to the luminous intensity, means of E proportional to I. Second law is the another name is the inverse square law. This in this law, the illumination of a surface is inversely proportional to the square of the distance of the surface from the source. In the mathematical portion, E proportional to 1 by r square. So suppose in this figure, here this is the source and this surface. So the distance is the x and another distance is ds, another distance is the cx. So this the surface ratio is 1 is to 2 is to 3. So there is all a solid angle. So surface this portion to this portion source to radius x to distance areas is the 1 and source to distance to this portion is a 3x means radius is a 4x square and this portion area is the 9x square. So if there is a ratio of this area is a 1 is to 4 is to 9 and there is in this equation because E proportional to 1 by r square, so value is the ratio 1 is to 1 by 4 is to 1 by 9. Next law is the Lambert cosine law. This In this law, E is directly proportional to the cosine angle made by the normal to the luminous surface with the direction of the incident lens. In other words, E proportional to cos phi. In this figure, suppose this question flux phi is the flux incident of the surface, the area of A. In the position of if this question is surface light is source present and this question is surface and this question flux is in area of A, this question is a surface is a flux phi. And when the surface is turned through angle is the theta angle, then the flux incident is phi cos theta. So when the if the surface is the one position number 1 and this is a position number 2. If so that when the position number 1, then this time the illumination is between the E1 is a phi by A. In the but when the position number E2, then the position this position illumination level E2 is the phi cos theta by A. But phi by A is the value of the E1. That's why we write the E2 equals to E1 cos phi. So after these three laws, we can together we get the E equals to I cos theta by r square, and this unit is the union per meter square or lux. Next question is the describe the advantage and application poreless induction furnace. First is the advantage of poreless induction furnace. So first is point is the poreless induction furnace is a fast in operation. Next, this is control and uniform quality product of the untertained by the other method. Just there's another is induction furnace, basically there's a poreless, port type, other this type. There is the another method is a pure uniform quality of the product obtained. And this makes it is the absence of dirt, smoke, and noise. And makes a crucible of any space that we use. And next is the eddy current in the charge result is active, automatic steam. And erection cost of the coalless furnace is less. Operation cost is a main point. Operation cost is very low, and this it is possible to operate coalless furnace. Intermediate as a no time is loss is warming up because when heat in induction furnace as a heat is produced in the operate, but there is a no is when it is produced it is a loss, but there is a no time of loss is warming up. Next is the application. This application is the production of production of steel, and also used for major non-ferrous material like gas, bones, copper, etc. And another application is that there is also used for specialized applications such as vacuum melting, ruthless steel, and heating such a non-conducting material. Use of by the use of conductive cables. The next question is the describe Newman method for indoor lighting calculation, and another is this part what is the Lambert surface. So first is the Newman method calculation. So first is known as Newman method. The other name is the light flash method. In this method, we implement for lighting calculation. We implement the course pieces for light source of the light to produce approximate uniform illumination over the working plane. So next part is a calculation. So in this method for lighting calculation, we use a total lamp output is determined and is determined by formula size of lamp or lamp comfort and lamp efficiency. And lumen receipt is the on the working plane are also determined by multiplication of the total lumen output from the source with their coefficient of utilization or coefficient factor. And in this case, if the surrounding or lamp is not perfectly clean because we use after the using there is a not is after using there is also a moisture and other dust is the produced because that's why lamp or surrounding is not perfectly clean. Then in the determination of the lumens received by working plane, there is also input dispersion depreciation factor or maintenance factor. So that's why the lumen received working plane is a formula is the lumen received is equal to number of lamp into wattage of each lamp into efficiency of each lamp into coefficient factor by depreciation factor. And also luminosity on the working plane we given as luminosity formula is the luminosity is the number of lamp into wattage of each lamp, efficiency of each lamp into coefficient of utilization into maintenance factor. These two equation is luminosity of the working plane we determine. Next is the Lambertian surface. Lambertian surface is for the reflection is a surface that appears uniformly being all direction and of view of reflect entire incident light. And Lambertian reflectance is an ideal method or diffuse reflecting surface. Next question is the discuss the various method of controlling the temperature in resistance profile. There is a types of resistance controller. One is the resistance furnace, another is the air circulation furnace, and two is the salt bath heating. The first is the resistance furnace, and in this furnace type of oven, used for cooling a heated job solely, and during the heating is known as the by the annealing. And this annealing, we usually process of annealing that left covered to stay oxide which has been removed in this order. And if we are to guide finish. Next is the air circulation furnace. Air and this charge means in this furnace, this the charge may not get uniformly heated in ordinary furnace. In heat, to transfer the charge by the radiation. And if such furnace air is passed overheating the element and heated air circulates over the charge uniformly or parts, and this is furnace is charged by the conduction method. Next is the question salt bath heating. And salt bath furnace is used for temperature and handling the steel. And this furnace consists bath of some salt such as a molten sodium chloride or two electrodes are immersed in it. When the electrodes immersed in the salt, they are passing heat and there is a heat is developed, and this temperature of the salt bath about 1000 degrees Celsius to 1500 degrees Celsius. And this transformation in heat it is the use in case of the by the conduction method. The next question is a mathematical problem. This question, a room is 8 plus 12 meter is lighted by 15 lamps to fairly uniform illumination of 100 meter square. Calculate the utilization coefficient of the room given that the output of each lamp is 1600 lumens. So our given data is the room area is the 8 plus 12 meters square. Next, number of lamp, because we discussed in question 16 lamp, and lumen output its lamp is the 1600 lumen. And next, the lumens emitted for this question, lumen emitted by the lamp is 15 into 1600. We get 24,000 lumen. Next, lumen received by the working plane of the room. So total is 8 lumen area into E into A or A into E. This is the lumen area, and this is the illumination. There is also told that use 100 lumen meter per meter square. This is the E illumination. Then calculate the equation factor. This is the and have this lumen received by the working plane and the radiation of the lumen emitted by the lamp is 9600 by 24,000. Then the value is the 0.4. If the coefficient is a percentage, it is a 40%. Thank you. Next video we discuss the another question.